All right, so we were talking about document store. Now, a document store, in a document store, everything is a document, and um, it is uh, it is going to give you an option of having a relationship between two separate tables. So we saw an example of that. Let's uh, I'm going to talk about that once we get to the diagrams again. The third type was the white column store. White column stores, they are a little restricting as compared to the other two, and it is going to have some form of schema defined. They're going to dictate that the outside column should be consistent across all the tables, and then the inside structure, it is fine. That can change. And then the last one that we saw was the graph database, and inside graph databases, uh, the the relationship between two nodes, it is called uh, the first class citizen. And the whole idea of graph database is that it gives priority to relationship between two entities. What goes inside entities is once again based on the NoSQL theory, that it is not going to have a very strict schema, right? With that, we saw a couple of examples of how the customer and order can be connected. Even though we store the values, it is it does not necessarily have a foreign key or any kind of validation. Uh, then we saw document store, and then we mentioned that there can be a connection between these two documents. Then we Okay, and then we looked at an example of the graph database. For today, I think I should start with at least one thing about the CouchDB itself. So give me 1 second. So my CouchDB has stopped running. Right, right. Let me go ahead and quickly pull up a command to start the CouchDB. I wanted to show you at least one thing. So a CouchDB starts with this command, and at, there is a spot where you'll have to provide the admin username and password. So we're going to enter this command, and then it will require some form of port mapping. And for that port mapping, I'm going to scroll back up and going to pick up this. So with these two defined, this is how I install and run the CouchDB. With this started, I'm going to see that everything is up and running, and it's saying that it started 3 seconds ago. And now I should be able to go to a URL like this, 127 slash this. Can everybody go mute, please? All right, thank you. So here I am in the CouchDB. The admin and password, the user ID and password is what we entered on the command line. And you can hit the save button here. And then yesterday we had a database here. Because it is a fresh start, we are not going to see a database, but then it is as easy as clicking on this button and entering the value like full stack DB, right? There are two options that we are seeing. One is partitioned and the second is non-partitioned. And then if I can go back to our whiteboarding, it is this diagram here. All right. if you click on partitioned, it is going to create multiple replicas of the data, and that's when it is going to be fault tolerant. For our demo purposes, I'm going to leave it non-partitioned, and I'm going to hit the create button. One thing that come on. One thing, yesterday we saw how to create a database on this document here. Okay, so I would want to use the right terminologies here because CouchDB is a document DB, and we have already created a database. Database name itself is FirstStackDB. All the entries inside CouchDB or this database is going to be document. And the way to create document is you hit that big button, create document, and then you will have to enter comma, and then over here you can provide different uh, elements, something like this. And then right, there are only these two entries that we have added. This ID is auto-generated unique key. Once I hit this button here, which is going to make it permanent, notice something that happens to this. Partition must not be empty. Okay, I wanted to create a non-partition database. I think I got that wrong. I'm going to hit on the database again. Let's create another database, a demo, and I wanted to create a non-partition database. So I'm going to hit create here, and I'm going to click on the create document button, comma, and then I'm going to enter the links value. My links. Once I hit this save button or the create document button,
Sir, you are on mute.
uh, I'm so
So you're
sorry.
mute.
How long I have been on mute?
After for 2 minutes, 2 to 3 minutes.
Okay, should I repeat something?
Yes, sir.
Okay, you should have told earlier. Um, I'm sorry. Okay. Did you guys follow this discussion?
Values
No,
part.
so you're muted.
Okay. All right. So let's go ahead and repeat this last part. What I did is I came to the database and I'm going to call it links DB this time, and I selected the non-partitioned option. Right? When I click the create button, it is going to provision a database. Now, each entry in this database is going to be a document. It's not going to be a row, it's going to be a document, right? Uh, Redis, it'll give you a primary key of ID, which they're going to use for indexing. And if you want to save something like links here, we can enter key value pair, and I can hit the create document button here, and that is going to persist it. Now notice that when we hit that create document button, we only had two entries here, ID and links. And then this revision was something that CouchDB added for some form of internal tracking. If we come here now and we modify those links and provide a value, this is an empty JSON entry, by the way. And if I hit now, this button has changed from create document to save changes. But when I save it, notice that the revision has changed from number 1 to 2, and there's another key here. The reason Redis does, I'm so sorry, the reason CouchDB does it this way is because the data that we have is going to get used by multiple um, users, what we are creating is a links database. Now, this is user number 1. Okay, this user can access data by going to different by by browsing through this API-like structure. So notice this this URL structure itself. So this is the Couch DB server. This is the name of the database itself, and this is that unique record that is identifying it. Now, I have not tried this before, but let me add a dummy parameter here. And it is another, say it is 10. And when I save it, go to this entry and hit the JSON link again. Okay, so I'm on number 3 with dummy. And then, okay, number 2 has kind of gone. So every time you hit the URL, it is the same URL that you're going to hit, and it is always going to fetch you the latest result. Now, suppose there are like 2 more users who are also requesting this data uh, from the CouchDB. CouchDB every time is going to come back with a revision number. Because we are in version 3 now, everybody is going to have this copy. Now, in case this third user decides to modify the data, it is going to send a request to the CouchDB, which is going to get honored, and Couch is going to save it with revision number 4. Okay, now in case this person decides that they need to modify that data as well, they are going to send their end of the update. Suppose they update the value of dummy to 20, and they're going to send it to CouchDB. And the way CouchDB is going to work it out is going to also ask for the revision number that they have in the update query. And then they're going to compare this revision number with what is present in the database, the latest value. And if these two versions don't match, this request is going to fail. All right, so this is a very important concept when it comes to document databases, that the revision number has to be passed every time before you would want to update the database itself, the document itself. Another thing is there are multiple keys into it, like links, and there was, I forgot what the second one was, and the last one was dummy. Every time you would want to update the database, you will have to set the entire load with the new value, but then the old values you do not remove, because if you remove this, the new update is going to wipe out all the other entries, and it is going to only going to leave what you send. So it's going to be version 4, but then um, these two properties will be removed as well. So your updates, they'll have to be very tricky. You will have to send the entire batch once again. So that is one thing that I wanted to show you about CouchDB. You can go ahead and give it a shot. It's pretty straightforward. For today, I wanted to move on to the next part, and that is the Redis cache. All right, so Redis is another open source implementation of Redis is another implementation of of a key value pair store, and um, the difference, or um, the way it is different, is that it is an in-memory database. Now, most of the databases that we look at, their values, the data that we create, as in this thing, it gets persisted on the hard drive. But then Redis has a different strategy, and Redis stores everything in memory, and that memory is like RAM. So it is not going to be persistent, and across restarts, you're going to lose all the data. The reason it is done this way is because it has a specific purpose. So Redis generally comes with another word by its side, and it's called caching. So when you have specific requirement that you would want to cache some data across the life cycle of an application, you have say a complex application structure. There are multiple computers, and then there are few settings like the theme, right? You want to have a dark theme. You would want to cache this value. You have say a connection string setting. You're going to save that string inside this particular data structure inside Redis. Now, the structure of Redis setup is once again what we saw in the sharding or distributed architecture scenario. So Redis is always going to have a server, and it is going to have multiple slave machines. So the server here is called master, and these machines here, they are called slaves. When you want to connect to this particular database, the request, they're always going to come through the server. And as you add different key and value pair to this, the server is going to store it, and the server takes the responsibility that the key and value pair, it eventually makes it to all the slave. The reason it does that is the server will always be up and running, and these slave nodes, they are going to take the load from this server structure. And as the load increases and the server has an idea of which slaves are active and which slaves have the latest data, it is going to route the new incoming request from the client side to these servers. So that way it is going to be super efficient. And if I am allowed to pull some statistics, a regular database that runs in memory, if it can process, say, 80,000 requests, right? I'm so sorry. Then CouchDB is going to process 110K databases, 110K rows. So the performance of Redis, because it is in memory and because of the architecture style, it is going to be a lot more performant than the regular database pulls, right? Once again, everything that applies to NoSQL database, like it is not going to have a schema, that thing is still present. And another advantage of Redis is that it has very good data support. The data types that we're going to get inside Redis is pretty strong. So let me show you how to install Redis. I'm hoping that most of you are on Windows machine. If you search install Redis, this is a little tricky for Redis. I don't know why, but then you will have to go to this link, download Redis, and search for the Windows operating system. So for Linux, you're going to run these commands. Sudo apt get. There's something for Windows. And eventually I found out that it is present inside GitHub. So you're going to go to Git and okay, so this looks a little neat this time, but then the last time I looked at it, it was tucked somewhere deep. All right. So if you go to the Redis page of the GitHub page of Redis, you're going to find some download link somewhere down below, right? Which will eventually take you to this page. And then this is the binary that you will have to download, right? But then now that you've been working with me for about 2 weeks, you would know that I am not a big fan of downloading such setups. I generally lean towards Docker, and let me show you if Docker has an option for Redis. And then if I do Docker Redis, Docker Hub page is going to show me that one binary image where Redis is available. So what is Redis? It's an open source networked in-memory key value data store with optional durability. Okay. The way I start Redis cache is I'm going to run this command docker run, and I'm going to give -d and the name of the image itself. We are going to have to expose a port, and you expose port using the -p switch. Now I'm forgetting the port number. I think it is 6379. Redis port. So it is 6379. So there we have it. We have our command here. So we're going to pick docker run. Docker run. Then I'm going to give the port number 6379. 6379. In the Docker section, we're going to look at this command more closely, but then -d and Redis. This is going to download the Redis installation for me, and it is also going to install it. So I don't have to take this complex route of finding out the setup and installing it through there. I'm just going to come and paste the link here, and I'm going to hit enter. Right. The way to check if everything is running fine is through Docker PS, and it is going to say that there is an image called Redis and it has started. Now, I have not been able to find a good desktop client for this. So we are going to go inside this computer the way we do remote desktop. Inside Docker, the remote desktop is done using this command. And I'm going to go inside. Notice that the prompt has changed from C drive to root, and then there's this number, and then this number matches with this computer. Right? This is irrelevant. Just understand that I am inside that I'm trying to access the Redis database itself. And the command for that is Redis CLI. Regardless of where you are doing it, from this point onwards, everything is going to be same for you and me. Once you have it installed using the regular way, you're going to launch a command prompt yourself, and you're going to run this command, which is the Redis CLI. Redis does not have a intuitive UI like this. And then for the rest of the Redis discussion, we are going to stick to this command prompt here. OK, notice that this URL is a lot similar to what we were looking here. Like just that CouchDB has a different port number. Redis has a port number of its own. Right. OK, so let me pull up a bunch of commands that I'm going to execute today. Just to check that everything is running fine. And you might want to record these commands, or I'm going to lean back to our old trick of I'm going to lean back on our old trick of finding out these commands. Right. So the first command that I'm going to run is ping. And notice when I finish typing ping, there is a little message alert, a tooltip kind of that I receive, which is kind of nice from the Redis side because it is very difficult to remember syntax of these commands. For now, I'm just going to hit enter and see what happens. When you run this command ping, the Redis server, something that we saw here, this box here is going to respond with this response here, pong, which indicates that that particular server or Redis is up and it's running fine. Then the way we have this command in all the operating system, we are going to run the echo command, and echo is going to give us the same output back. But then our actual objective is to use this particular framework application in caching some values. And then to cache a value, the first command that you're going to run is set. Right. And then notice the nice tooltip that we are receiving. So it's the set keyword or the set command is going to require a key. Let's call our key foo, and then I'm going to enter value as 100. OK, I'm going to ignore the rest of the options. I'm not going to fill up those, and I'm going to hit enter. And notice that the response that we received is OK. Now, the opposite of set is actually get. And if I do get and type the key and hit enter, it's going to come back with that value. Right. So the value that we had set in foo, we are kind of retrieving that value with the get command. Now, Redis is case sensitive. So these keys are case sensitive. So all small foo is different than capital case foo, right? And then the response that we received is nil, right? So when you try to extract a key that is not present in the database, it is going to come back with nil. Let's move on. Let's add a couple more keys. I'm going to add another key as bar. I'm going to call hello world. And if I hit enter, it's going to come back with an OK command indicating that this value has been saved. I'm going to run the next command bar, and then let's see if that values comes back. So we were able to add at least two keys. One is foo, one is bar into our Redis cache. There are Now, there are different commands using which you can influence the values of these settings. So one such command is increment. And for increment, you're going to type incr and notice that it is asking for a key. Let's see what happens when we run this command on foo, and it has bumped up to 101. And this time it has printed the output. This is the same output that we'll get if we type foo here like this. So the increment output is almost like uh, the get command on that key with the new value. Okay. Now, generally commands, they come in pair. So if you have an increment command, you will also have a decrement command. Right. So it is going to keep decrementing the value. And then I think these commands, they are case insensitive. Okay. So these two commands, they are both going to work the same. Right. If you want to get rid of a key that you have already added, the command is del, and then I'm going to delete the bar key. So before that, let's see if it is still present. So the bar is still present. I'm going to run the delete command del and type bar and hit enter. And and then this one here indicates that it is successful. Now, if I do get bar, it's going to say nil because we have deleted the key. There is at least still one more key in our system, and that is foo. Right, so foo is present. Let me set bar to once again, and I'm going to say hello this time. Now, if I want to delete all the keys that are there in the system, I have a command called flush, and flush all is going to delete all the keys that are there in the system. So now if I do get foo, it comes back with nil. If I do get bar, it comes back with nil. So no, there are no, I mean, flush all has removed all the keys that were there in the Redis cache. Now, the reason we need this kind of these commands is because of the purpose of Redis itself. Now, Redis is not a transactional application. Redis is not for storing the items in the shopping cart. Redis is something that is present in memory, and the usage of that thing is more on the side of something that can be passed across multiple servers with great speed. And then it is because of that that we are always going to keep it very lean. The size of the data that you would want to save in Redis, it should be fairly small. And that is just my evaluation. I have not come across any such restrictions. But then because it is a caching strategy, it is an in-memory strategy, and memory uh, is a limited resource. You would want to be very considerate about what you want to put inside cache. All right, and then such commands, they are going to help you quickly add something to the cache, um, spread it across multiple servers, and then those servers will be able to extract those values out. And then when you are done with that particular cache, a command like flush all is going to get rid of everything that you had cached in the system. Okay, with that, if you have a specific strategy that a value should be cached only for say 30 seconds or 1 minute, you can do that as well. So let's clear screen. Let me increase the font size. I'm so sorry. I don't know if you guys were able to see it earlier, but let's go ahead and add a new value once again. Hmm, I'm going to, okay, let me go ahead and close out of this and start Redis CLI again. I'm going to type set foo, and I'm going to enter value 100 this time. Now, this value is going to persist across till the point where I delete it or I flush everything out, right? And then this value will keep coming. There's a command called expire, and notice that it takes two parameters. One is key and the second is the time, which is seconds. So if I give foo and enter 60 here, this value is not going to be available after 60 seconds. But then just to find out how much time is remaining on that particular key, there is another command. It is called TTL. TTL is short for time to live. With time to live, if I enter the key here, it is going to say 42 seconds, right? If I run this command again, it is going to say 39 seconds. And then after 1 minute, we are not going to have access to this particular value. But in case you change your mind and you were like, you know what, this value is still good, and I would want to probably get rid of that thing, or probably not want it to expire, there is another command which is called persist. And if I give foo, and now if I do TTL and do foo again, it is going to say -1. Now -1 is a special value and it indicates that foo is never going to expire. So let's go ahead and run the expire command again. And this time we're only going to give it 5 seconds and do a quick TTL foo and see that it has still 1 second remaining. And now if I do TTL foo, it is going to say -2, and -2 would indicate that it has already failed. Let's repeat this example with bar. I'm going to do set bar to 200. I'm going to do get bar. It's going to get me the value. I'm going to do expire bar within 30 seconds. And let me do get bar this time. So when I do get bar, it gets me the value. When I do TTL bar, it tells me that there are 23 seconds more left. And so what I wanted to demo here is that before the time expire, you can keep running the get command, and get command is going to come back with this value. TTL is going to show you how much time is left on the clock for that particular command. And after this, if you run that command again, right, -2 indicates that it has already gone. Now, if I do get bar again, bar, right, it's going to come back with nil. So the value has expired, and this particular entry is not available in cache. And that is one of the expectation from a cache behavior. The reason you cache data is because fetching data from the actual hard disk is a long IO device time intensive process. And it is not always efficient. And then to increase efficiency, you cache those values. But then there are chances that because we are using the cached value, the value in the hard drive, the persisted value might have already changed by some other process. And then that's why it's a good strategy to assign a life cycle, a lifetime to these cached values. And after that, you can go ahead and probably retire them, expire them, and then fetch a new current latest value from the hard drive one more time. Now, it would get very complicated or time consuming if you can add only one value at a time. So for that, Redis has has another command, which is mset, and mset is, let me go ahead and flush everything. So mset is going to let you set multiple values in single command. So if I start with foo 100 and bar 200 and zeta as 300 and hit enter, it's going to say OK. And now I can do get foo, right? And it's going to come back with the value. And then we were able to save everything in one command. So you can keep adding multiple keys with the mset. So provide a key and a value combination, and mset is going to add all of them together. Right. So that was Redis in short. Redis has multiple options for you in terms of data types. The data type that we were looking at so far is integers and numbers. But then Redis also has option for list. We were looking at strings so far. Redis has a list, sets. Then there is something called as sorted sets and hashes. Uh, the way they are different is a list is going to be a collection of multiple items, and you can you have an option of adding members at any spot, like in the beginning or in the end, and printing all the values that are present in the list. Now, once again, this is going to come in handy when we are working on information uh, like the navigation bar. If you want to store a collection of all the links inside cache because you are generating it multiple times, you're going to rely on Redis on the list data type of Redis. Sets are more like what we have studied in the set theory, that there are elements X, Y, and Z in this particular set, and you want to take a join on this particular set which has X, A, and B. The output of this is going to be a new set of the commonalities of the union between two, and that is X. So Redis has uh, a nice set of commands of storing values in set and then performing operation on different sets. So that is an option. Uh, and then these sets, they can be sorted, and that is another data type of Redis, which is called the sorted set. And the last is the hash value or the hash data. Now, hash comes in effective when you would want to store values in the form of key and value breakup. And then using the key, you would want to perform some form of mapping between the data that is coming and the value itself. So suppose there's a person, the person has is born in 1980, and the value is say Zia. I was not born in 1980, by the way. So uh, when you want to store this kind of information, you're going to rely on the hash feature of Redis. So let's quickly jump back to our demo, and we're going to see example of some of these, like not everything, but most of these. So we have already seen this. Okay, I forgot showing you one command, which is setx, and then this is notice the tooltip. I'm going to give it say key 1, and then this is going to expire in 10 seconds, and it's going to have a value of 100. All right. So by the time I finish my water, the key might have already expired. All right. So setx is going to let you set a key with an expiry value in it. Let's go ahead and flush everything out and start fresh on the list side. So for list, the command is L push, and then once again you can create you can provide a key here like people, and then I can start entering names here. So everything that I enter here, uh, it is going to become part of that people list. So you can provide one value, you can provide a space separated multiple values, and it is going to have 3 elements inside this list. So L push is pushing on the left side of the of the list, and then the way to see the value is L range, and then I'm going to provide people, and then it says that there are arguments that I'm missing. So let's go ahead and start again. L range people, and then it's asking for a start value. Now, if you are familiar with programming, all the indexing starts with 0, and then there is a stop value that you can provide. So if I want to retrieve only one value, I'm going to type 1 here and hit enter, and it came back with 0 and 1, like the index 0 and index 1. If I want to go all the way to the end, I'm going to provide -1, and it is going to retrieve values differently. And notice the order in which we entered John, Steve, and Mary. The way it is coming out is the other way around. It started with Mary and Steve, and then John in the end. So the values are getting pushed on the left hand side. If I want to do it the other way, the counterpart is R push, and then I keep the key same, and I can probably put my name here. and then my name is going to get added in the end. So if I run this command again, lrange people 0 minus 1, it has added my name to the right side of the queue, and I'm appearing like last in the chain. Okay, there are two more commands. If you want to delete an element from the collection, the command is lpop, and it is going to pop from the left side, and then on the left we have Mary. So if I run that command, it got Mary out. And notice, if you remember the concept of stack, pop is always supposed to return the value that it currently popped, right? The counterpart is rpop, and on rpop we are going to get probably my name, Zia. And now if we run the lrange command and give it people key and print the entire collection, it has only come back with two elements because two elements have been removed from the collection. Make sense? So this is the list data type, which is going to have an array-like appearance, and then you're allowed to put values on both the ends using L and R in the command. So lpush is going to push, lpop is going to pop from the left, and then rpush and lpop are going to perform operation on the right side of the queue. And lrange is going to print values on the start and stop index from this particular list. Moving on to the set part of it. Now sets are a little different. So let's go ahead and flush everything once again. I'm going to hit enter. And for set, the prefix is S, and then you hit the add command because it's a set you're going to add and remove elements to it. And over here, let's use an example of cars. And I'm going to add the first card as say Ford. I can go on adding more elements like say BMW, and then let me add another right at the same time. So this is how you add element to a collection. This one added one element. The second command added two elements. The way to now there are operations that you can perform in a set. So a set is probably represented with commas, and then it's going to have members X, Y, and Z. If you want to check if X is a member of this particular set, you can run a command called S is member, and then provide the keys cars. And over here, I'm going to put BMW, right? And then it came back with a result indicating that this value is present in the members collection. Now there are more commands starting with letter S, and as you hit the tab, it is going to show you those. But then what I want to do is I want to print the entire collection of set, and I'm not able to recollect the command name itself. I'm going to come to Google and I'm going to type Redis commands cheat sheet, and then hopefully I'll find something interesting. Right. Here I'm going to search set, and then set has key and value, and there is something called as mset. It's going to let you enter. Okay, I'm going to type the command s add. So I can add member. I can add a member to a set with the key. I can remove it. I can see if a particular value is a member, and then there is another command called s members. So I'm going to run that command, and it is s members, and I'm going to type cars here, all small, and it is printing all the members. Now, one of the set theory expectation is that you can pass a cross section or a cut of this particular set in another set, and the command for that is called smove. When I do that, it is asking for source cars, and then I'm going to create another set here. I'm going to call it my favorite cars, and I'm going to say BMW. So once I run this move command, right, there is one member that got selected, which was BMW, and before this command was ran, my favorite car did not exist. So if I type my favorite cars here, and oh, not as move. I'm so sorry. It is CLI. I wanted to print S members and provide this value here. Now, if I hit enter, notice that My favorite car has one member, which is BMW. And if I run the command again as members and try to print value of cars, it has come back with only two. So before we started, it had three members, the cars set, and after the move command, we moved the BMW out to a separate collection. Now, this way of these commands, they are extremely handy when you have uh, when you want to perform set-like operations, right? On the similar lines, we have sorted sets, and then sorted set, instead of S, they start with Z, and then instead of SAD command, it's going to be ZAD, and then the structure is going to be almost the same. Uh, you can increment the values, you can perform direct operations in these members. So I would encourage you to go through this cheat sheet and try executing these commands on your Redis installation. All right, so it is 9:15 on the clock almost. Let's take a quick 10-minute break, and then when we come back, we're going to talk about databases in Azure, and I'm going to introduce you to the Neo4j, the graph database. All right, thank you. All right, guys, I am back. Let's jump into the next section of the course, and let's talk about databases in Azure. So I'm sure that most of you, you might have not worked on Azure. So we're going to start with, I'm going to walk you around Azure real quick. So Azure is the cloud platform by Microsoft, and it is accessed with the link portal.azure.com. If you have not already signed up, go ahead and sign up, and you'll be presented with a screen like this. Now, I'm going to go on the home button, and I'm going to click on create a resource. Now, um, the specialty of cloud is that cloud has everything that you will do related to computers, related to application development. Cloud will have a matching service. So suppose if you want to create a web application, you have an option of creating an IIS-like server over here. If you're working on databases, you are going to get an option like this over here. Um, if you want to do load balancing is going to be available somewhere under networking. If you want to do some form of security, Active Directory, all those options, they're going to have a matching entry over here, and you will be able to create those resources. What we want to create today is an Azure table, which is Azure's implementation of NoSQL. And to start that, you're going to have to start with a storage account. So I'm going to search and create what is called a storage account and hit this create button. Now, one of the most important thing in cloud is the resources that you're creating, the computers, the networks, the firewall settings, the Active Directory, they all should be collected together. Uh, they all should be collected together. They should be logically bound together. And right, so on a screen like this, where you are trying to create a resource in Azure, a resource group is a logical boundary across um, the computer network resources that you're going to add. So a general strategy is that you enter uh, the project name probably in short. So I'm going to say full stack developer FSD. Then I'm going to talk about the application itself, and we are creating, say, a demo application. And then because it's a resource group, I'm going to add RG over here. Not a requirement. You can give any name that you like. I'm going to create a new resource here and provide this value. And then there is a storage account name that I'll have to give, and I'll have to be very unique here as well. So I'm going to say FSL, and then because we started in May 2021, I'm going to say FSL May 2021. And then I'm selecting the East US region with the standard everything. Now I can, through the rest of these screens, you can read it later, but I'm just going to skim through. They are all default settings and I'm okay with them. And when I come here and create this, it is going to take a quick moment. It is going to do a quick validation check. And once that validation check passes, this button is going to get enabled. And once I click on this, Azure is going to, in the background, it is going to run a bunch of scripts, and it is going to provision that particular database for me, or at least the resources where I can go about creating these storage activities that I'm doing. Now, while this thing is happening, it's not going to take a lot of time. One of the misconceptions of cloud is that cloud is this collection of super massive, super amazing computers that never go down. That is incorrect. Cloud is a collection of commodity computers, or that is what I understand. A commodity computer is something that you and I, we use for our day-to-day work. And the way these computers are arranged and connected, and they are exposed to the outside world, that is what makes it very interesting. So these are like simple servers, and these servers, they are bound to failure. But then the overall topology or the structure of arrangement of these computers, this is what makes it very robust and failure proof. So while we talked about that, our resource here is created. I'm going to click on the button, go to resource, and on this resource, I'm presented with an option of all the type of storage that I can do. So blob is a binary large object. If you want to store videos and things like that, you're going to interact with a blob service. A file service is where we're going to save our files. Queue services is something for a distributed application. We, for today, are interested in the table services. So I'm going to click on table services and notice that I have an option of creating table. So compare this with what we had been looking at for, okay, my CouchDB is dead, but then no, it is not. So there was 127 this slash underscore utils, right? The way we had interacted with this was we went ahead and started creating databases and documents inside these databases. Azure is giving us a similar option of creating a table over here, and I'm going to call this, say, demo table. And okay, so scores are not allowed. I'm just going to say demo and hit the OK button. And notice that this demo table is already provisioned. Now I want an option to go inside this table and see what values are present. And there's a nice handy URL over here. I'm going to come copy paste, and it looks like the resource is not accessible. Okay, so this is not the place from where we're going to enter these values. And then if you look around these options, you're going to find something called Storage Explorer. If you go inside this, and then the four options that we saw earlier inside the storage account are also presented here. We're going to go inside tables, and in demo, we have this nice option available over here. Now, as against the other um, NoSQL platforms, Azure is going to give you an option of having queries. So queries are something that you can provide here. And then notice that at the moment, there are only two columns or two fields that are present here. One is called the partition key, and the second is called the row key. Now, partition key, if you remember the concept of sharding and distributed architecture, partition key is the unique identifier, which is going to help us identify on what server we are going to be. We're going to drop our databases in one of these five. We're going to assign one partition key to each, and oh, excuse me, one partition key to each, and that's how we are going to enter values. So let's go ahead, close out of this query, and let's add an entry or an entity to this database. Now, once again, these two are not optional. I cannot even switch their types. So I'm going to say that this is partition 1, and the row key is also 1. If I want to save, say, links, the way we were trying to save all along, I'm going to say links. And then there are these many data types available over here. So string, Boolean, binary, datetime, GUID, and two type of integers. I'm going to say hello world. And let's just change this link to message. Right now, when I hit the insert button, this value is going to get inserted. Let's go ahead and add another value. And then this time, I'm not going to say message. This time I'm going to say I want to store student name. Right, I'm going to say my name here and hit the insert button. So notice that, okay, I did not provide any value to this. Let me go ahead and see if I can modify that now. All right, so I've missed entering these values, and then it still let me proceed with it. But then I would have changed the row key. I would have kept the partition key the same. Notice that we never entered timestamp. Timestamp is something that got added. It is very similar to having a revision in the CouchDB. And then in rows where I had the student name, right, the value of message is null. Right, and then in rows where we had message, the value of student name is null. So once again, um, this goes back to the NoSQL funda that the schema of these tables are not defined, and each row can have its own independent set of values and columns. All right, so these are the columns that you would want to see. You can apply smart filtering and you can remove some of these columns. You can order them and the related results are going to get pulled from the system. So this is like a very quick short summary of how you can do NoSQL databases or Azure tables. And we're going to see Azure in more detail in the last week of this course. All right, so go ahead, create an account in Azure and then play around with these options. There are multiple tables that you can create. Let's see if we can query something. Right. So I'm going to get data from key one, and then it came back with this result. And then probably because we have already removed the message column, it did not appear. But if we add that, notice that for this particular query, it came back with that result set. So you can perform all the CRUD operations. If I open this up, over here you have an option of modifying this. That is, I'm hoping that it is going to modify. It's going to modify the timestamp as well at which it is getting saved. So it was T3 first. Now it is okay. Probably the time changed. Okay, so the CRUD operations, they are all available over here. But then the power of cloud, it lies in your ability to use it from the code and use it from scripting. And then we are going to see .NET in the next week. And then probably we're going to see an example of how to modify values of these tables using C#.NET. Okay, so this is Azure tables for you. Very straightforward. You can give it a try yourself. We're going to move to the last topic for our databases section, and then it is called Neo4j. So Neo4j is a graph database implementation. And then if you remember our discussion from here, so a graph database is going to have nodes and it's going to have relations. And in these relations, they can create, they'll help us create structures like this. So my name is in the center. I have an address with this particular entity. So all the nodes, they are um, like tables. They are schemaless, and inside these entities, you can enter the value that that you want to save. And then over here, you're also going to define a relationship, right? So if I like somebody's message, um, I you can introduce a relationship between these two entities and define that relationship with an arrow from one entity to another. Now, Neo4j is an implementation of this. Of course, not the only one, but a very significant one. So uh, I am I'm going to look for a sample database of Neo4j, and I'm going to walk you through multiple steps. But then before that, let me show you another example. All right, so up until now, the relational database diagrams that we were seeing, they more or less, they looked like this. Now, this is a very small diagram. Let me look for a high resolution. This is better, but then I was looking for something more complex. Yes, this looks better, right? So when you're working in a complex application, you're going to have a lot of entities, and those entities, they're going to have relation. So this is one-to-many relationship. There's a members table, there's a food table, and in this members table is connected with member invoice, member meal, member dietary needs, probably, right? And then if you want to identify, if you want to extract data that shows a relationship between member and status, you're going to have to write a very, very complex join query. because there is no direct relation arrow that we are seeing, you might have to jump from say member table to this table, and then eventually you're going to get this. And then the complexity of the query is going to be like one aspect, but then the number of records in all these tables, it is going to contribute to the time it is going to take to establish the relationship between these two entities. And now it is very counterintuitive that a relational database does not have a very good way of hopping through multiple relations and coming to this data. And that is what makes it very challenging. And Neo4j and graph databases solve exactly that problem. They say that if two entities are related, uh, we should we should save the entity themselves, but then we should also worry about the relationship between those entities. And those entities, those relationships, they are saved in a different way in graph database. So let's go ahead and search for Neo4j sample databases, and I'm right on the Neo4j website once again, and they have some example databases available that we can directly consume. Okay, give me 1 minute. All right, I was looking for a built-in implementation, and it is somewhere over here. I'm just having difficulty finding it. Graph platform, database example, and this guide here, because I'm constantly coming back to this page. So there are a couple of databases that they have created, and one such database is the movie database. And there's a better link to that. Yes, this one here, that's what I was looking for. Okay, so I'm going to share this link with you. Now, this database has a small trick. The database name itself is the username and password. So if you want to try, you can go to Neo4j Labs and search for a movies database and hit the connect button. The way so far we were creating tables and documents in the relational database, and up until now, Neo4j has a different storage mechanism. This little blinking cursor that you see is where we are going to enter the query, and all the query, they have a specific format. It starts with a parenthesis, and then it has an arrow sign, and then it ends with a parenthesis. We're going to have entity over here. We're going to have an entity over here. And on this arrow, we are going to define the relationship between those two entities. Okay. But before that, let's go ahead and take a look at the database itself. So the movies database has at least two type of node labels in it. Okay. And the terminology is a little different here. They don't call it entity. They don't call it document. They call it node. Okay. And then a node, they have movie node and they have the person node. Now, when I click on movie, notice something that is going to happen on the movie screen, right? So it ran this query here, which is called match, and then n colon movie return n limited to 25. So what we are seeing here is 25 movie names in the form of different nodes. It's the same for the person node as well. When I click on person, it has come back with 25 person, and they are all different nodes in the system. Make sense? Now, right below it, we see relationship and relationship types. Now, a person probably is an actor and movie is the movie itself. So if you want to find out how a person and movie is related, there are multiple relationships that are there present there. One relationship is okay. So this little query here indicates how many relationship exist between movie and the person. And there are 253 relationship. If I run this query, notice the pattern that I spoke about some time back. There is something called as match, then there is a pattern P, and then it is identifying uh, one entity related to another entity, and it is returning the P, and it is limiting to 25. Let's go ahead and type that query ourselves. I'm going to type match P equals arrow and then relationship, and I'm going to hit enter. Uh, Match must return this clause. Let's go ahead and type this. Okay, let me close out of this. Let me close out of this. All right, I am not sure, but then there is something called as all right. So this output here, it has all the 170 labels of movie and people, and it is displaying how these entities are connected, right? So we wrote our first query where we selected uh, all the relationship between all these nodes, and it came back with this data. Now let's run another query which is acted in. So it is only going to show the movie in the center and everybody who were the actor in the center. Okay, so there's JT Walsh. If I click on this second query, notice that the query syntax here has changed. Now it is saying match. It starts with a match and it figures out that one result, and then it defines the relationship in these square brackets. So R is short for relationship separated by colon, and then the relationship itself kind of goes in here, acted in the other entity. So all the nodes in the database that are connected with this relationship, they are going to get selected because of this clause, and they're going to get assigned to this P here. And then we're going to do return P, and return P is going to return the result to this particular UI, and it is nicely drawn for us here on the screen. So we would know that a few good men, it had about 10 actors, and then they are all listed down here. Notice that this person here is sharing one special relationship, which is wrote. So he also acted in the movie, and then he also is the script writer of that particular movie. So you're going to come back with some fancy results when you run queries in this format. There is another query called directed, and then it is going to find out that who is the director of which movie. So this guy, he directed this particular movie, but then he acted in another movie. Okay, and then this is when these queries, they start becoming very, very interesting. Now this kind of database, it comes in very handy when you want to find out that tell me all the movies that John Patrick directed and which Tom Hanks has acted, right? So so the questions that we were asking in relational databases so far, they were more like how much sales happened in this month. And it would go and it would do some BI and maths behind the scene. And it's going to come back with, say, we were able to sell 200 laptops and 500 mouse and 500 pairs of monitor, right? So relational database has a specific use. But then inside a relational databases, if I ask you a query like this, that tell me the people who bought laptops, who are they friends with, and what are their friends buying, and what people who buy laptop, what other products they buy. When you have such type of query, relational databases, they work, but then they have a performance issue because a relationship is not a first class citizen there. But then imagine it will be very straightforward this time if I put my query like this, that the director is John Patrick, and then I want to find out movies where he worked with Tom Hanks, and then I want to find out those actors who were also part of, say, related to Tom Hanks's other movies. So the jump that you make in those in this data structure is extremely straightforward, and it kind of comes back really quick with the result set. And then if I have to, if I can pull an example of this particular structure, I'm going to pull up a quick comparison chart. Let me see if I can compare that like right away. I had seen a nice comparison chart somewhere. I'm trying to figure that out. Let's do that here. Relational database performance. So there was a nice statistics that I had seen somewhere. Right. All right, let me just go ahead and draw it on the screen. So uh, the problem statement was that this is a social media site, something like Facebook. My first level of friends are these people with whom I'm directly connected, right? Their friends are also present over here, and then they have their own friends, right? So it goes on like this, that my friend, friend of friend, friend of friend of friend of friend, and so on and so forth. When you want to identify that who is in the fifth hop away from me, the kind of query that you're going to write in relational databases, they come back with different performance parameters. So the first hop is from me to my connected friend. The second hop is my friend's friend, and it goes on like this. With a, I, I don't remember the data set, but then relational databases. Let me put relational databases over here. All right, I don't know what happened. All right, so let me put relational databases on this side and graph databases on this side. When the performance analysis was done, graph databases for the first time took about 30 milliseconds, and then the graph databases came back with about 10 milliseconds, if I have these statistics right. This time around, it took about 20 seconds, and then it was still sub-zero. So it was still less than 1 second. And then after that, it went up to 3000 seconds, and it was still 16 seconds or something. And then when it was probably given 1 million records, with 1 million records, it was never able to solve it. And then probably it came back with 3 minutes or something. All right, so these are roughly the performance indicators of this thing. So when you have to do multiple hops and keep applying joins at multiple level, relational databases take a very big hit on the performance, while as the graph databases, they are well within the acceptable range, right? And this is what makes them very lucrative, very attractive. Um, Once again, it is very difficult for us to remember the syntax of these queries. So what we were seeing here, it is difficult for me to remember the syntax because I have not worked on it too much. But then once again, we can go back to our old friend and we can say Neo4j cheat sheet. And this cheat sheet is going to show you all the queries that are possible. So how can you match one single node? How can you match a relationship? How can you, probably there was something for count as well, that you match something and then you come back with a count. So I can say match movie and then return count. Let's go ahead and give this thing a try. Instead of n, I'm going to type movie and I'm going to type count as well. And let's see if this works. Okay, so there are 171 movies here. I can pick up multiple queries from over here and try to figure out how many relationships are there. So find out entity that has a relationship with another entity and give me the count of that. Okay, so these are like some of the tips that you can use and write complex queries. Right, so with that, we are going to end our session for today, and I'm going to pull up the training calendar. So we are in the end of week 2. Tomorrow, I'm going to communicate a message. Tomorrow, there's a guest speaker. He works for Microsoft in the databases team for about 8 years now. And then he's a database expert. We are arranging a guest talk from 9 to 10, definitely for him. I'm going to communicate the plan before that, but try to attend his session. It is going to be very interesting. Right? So with that, we are done with our week number 1 and 2. Right, we have covered HTML, CSS, JavaScript, and jQuery in the first week, and then we have touched a lot of databases. We have touched SQL database in great depth, and then for NoSQL, we have understood the concept, and we have seen examples of Redis. We did not do Mongo, we did CouchDB. We saw Azure SQL, Azure Tables, which is NoSQL implementation of uh, Azure, and we saw Neo4j database. We just scratched the surface, but then these technologies are pretty straightforward, and you should be able to get started and apply these concepts in your real life projects. Okay, so that's it for today. Thank you so much. I'm going to stick around for another 10 minutes. If you guys have any question, feel free to ask.